All right, welcome back. And now we're going to do example 2. So we're going to use everything we learned, and we're going to sketch the graph of this polar equation. Okay, so we've got a couple of things to look at. So first of all, let's talk about symmetry. Okay, so what kind of symmetry does it have? Well, it is a function of cosine, right? So r equals a function of cosine theta. Okay, so if it's a function of cosine theta, then it's going to be symmetric with respect to the polar axis, right? So that implies that it's symmetric with respect to polar axis. All right, so there we go with symmetry. Now, what is the maximum value of r, right? So what is the maximum of absolute value of r? Okay, when does that occur? Well, think about it. So what's the maximum value that this can have? This is just going to have 1, right? Which means this is going to be 2. So this is going to be 1 minus 2, which is negative 1. Or if this is 0, so when is this 0? It's 0 at pi over 2. And so when this is 0, this whole thing's at 0 is going to be 1. Okay? And so what else do we have to do? Negative 1, right? So when is this negative 1? This is going to be negative 1 at pi. If this is negative 1, then this becomes positive 2, which then 3. So the maximum value of this function is going to be at 3. So r equals 3 when theta is equal to pi. Okay? And when is r equal to 0? When does r equal to 0? Well, this is going to equal to 0 when cosine is equal to 1/2. So if cosine is equal to 1/2, this will be 1. 1 minus 1 is 0. So when is cosine equal to 1/2? And that's when theta is pi over 3, right? So when theta is equal to pi over 3. Okay, so again, this is why it's important to know your unit circle. Because if you memorize your unit circle and you know what these special angles are, and you know the sine, cosine, and tangent of these, then you can get a lot of this information quickly. Okay? So, now what we're going to do is we know the maximum value is 3 at pi, when theta is pi, and the function is 0 at pi over 3. Okay? Or r is 0 when pi over 3. And we've got a bunch of other values too that we can find. So let's get the table of values, right? And what we're going to do is we're going to go from 0 to pi. Okay? Because it's symmetric with the polar axis, all we have to do is go from 0 to pi and plot those, and then use symmetry to plot the rest. So we got theta and r. So we got 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi. So now, when theta is 0, r is negative 1. We saw that earlier, right? This will be 1. 1 minus 2 is negative 1. And then pi over 6, that's going to be a little bit difficult. So it's going to be 1 minus the square root of 3, right? Because we're going to get the square root of 3 here. Pi over 3, we know that that's going to be 0. At pi over 2, we're going to have 1. because at pi over 2, this is 0. And then at 2 pi over 3, we get 2. And then 5 pi over 6 is going to give us 1 plus the square root of 3. And then at pi, we're at 3. Okay? And so if we sketch that, so at 0, we're at negative 1. So we're right over here, let's say. And then we're going to go to 1 minus something more negative than 1. So that we're going to be not quite 1. So we're going to be over here, let's say. Okay. And then at right? So at pi over 6, oops, hold on, wrong way. So you got to think about this. At pi over 6, we're going to be negative. So at 0 or negative 1, at pi over 6, we're still negative. So pi over 6 is over here, which means we're going to be like there. And then at 0, so at pi over 3, we're at 0. And then at pi over 2, we're at 1. And then at 2 pi over 3, we're at 2. Right? And then let's say we go to here. And let's say we go down to here at 3. Okay, I'm just exaggerating. So far, what do we do from 0 to pi? What would happen? 0 to pi, we went from here to here to here to here to here. Like so. And then what do you think is going to happen? It's going to continue, right? So it's going to be symmetric, so we're going to put a point here, and a point here, and a point here, and a point here. So it's going to continue on like so. And we're going to get something that looks like that. And that's called a limison, if I'm pronouncing that right. So note that the negative r values, right? The negative r values are what determine this inner loop, the inner loop here. And the positive r values are what made the outer loop. And notice that it's symmetric with respect to the polar axis. Okay? If it was sine, we know it would be symmetric with respect to the line pi over 2. So here it's going horizontal. If it was sine, it would be going up and down. So whether the loop is on the bottom or the top, the inner loop is on the bottom or the top, then that might determine something else. Awesome, that's it. Have a great day.